Hello students, this is Professor Chalai, and in this video we're going to look at dilution of solutions. By the end of this video, you should be able to perform dilution calculations. As always, you can follow along with our chapter workbooks. Now before we get into the actual calculation itself, let's just look at what dilution is. Let's suppose that you have some concentrated solution, let's use a dark blue for that color, and you wanted to create a new solution that's less diluted. What you would usually do is take some of this, or even, take some of this new solution, add it to a new container, and then add solvent such that you create a new solution to whatever new concentration that you would like. So you take some of the original solution, or sometimes even all of the original solution, and add solvent to it. And that's how you create a diluted solution. But more than just creating a diluted solution, what we're interested in is calculating exactly what the new concentration, the new solution might be. And to do that, we use this dilution equation, M1V1 is equal to M2V2, where M in this equation, there we go, where M in this equation represent the molarity or concentration, and V represent the volume of solution. In these cases, 1 represent your starting case or initial condition, while the subscripts 2 represent your final or ending case. So in this equation, if we're looking at this solution, our starting solution would have some starting concentration M1, and the amount that we took, that we transfer over, will be V1, whereas in the ending case, our ending concentration that we're probably interested in is M2, and our total volume is V2. Let's see this in practice. We're going to do, for practice, some of these questions. Here we go. Numbers 29 through 32. Just to note that from the text that you have, I've made some corrections. I've added 1 liter of solution to the first 2 questions, number 29 and number 30. And for number 32, I've added this 0.500 molars. So now that you know the equation, try to pause the video here and do these 4 questions, and unpause and go over them if you think you need to check your answers. Okay, let's look at number 29. 29 says that we start with a 1 liter solution of 0.100 molar concentration of NaOH, and our final concentration that we're interested in is 0.0592 molars. So if I were to write this in terms of M1 and V1, M2, V2, our starting concentration, M1, is 0.100 molars. Our initial volume that we take, or we're using, is 1.00 liters. And our final our final concentration, M2, that we're interested in is 0.0592 molars. This means that what the question is asking us to find is to what volume in liters should we dilute the solution, meaning to what's the value of V2. So let's set this up. We know that M1 V1 times V1 is equal to M2 times V2. We're interested in V2, so let's solve for V2 by dividing both sides by M2, which gives us V2 is equal to M1 V1 divided by M2. And usually I like to simplify our equations in this way so that we can quickly solve our problem. So if we just fill this out, we find that V2 is equal to, the value for M1 was 0.100 molars. The value for V1 was 1.00 liters. And the value for M2 was 0.0592 molars. So the molars cancel out, and our answer will be in liters. And if you just plug all of this in a calculator, we end up with a value of 1.69 liters for V2. Three significant figures because we have three significant figures there, there, and there. Similarly, for number 30, we find that the final volume that we're interested in is similarly M1 times V1 over M2. So we just plug our values in. M1 is the starting concentration, it's 0.123 molars. V1 is our starting volume, 1.00 liters. And M2 is our final concentration that we're interested in, 0.00678 molars. And so if we plug all of these in our calculator, we find our answer is 18.1 liters. All right, let's look at number 31. 31, our initial volume, V1, is 10.00 milliliters, and our initial concentration is 0.100 molars. And here, we're asking to find M2 because we have V2 as well. So this is V1, M1, and this is V2. So quickly, if we were to write this equation, M1 V1 is equal to M2 V2, and we're asked to find what is M2, we can rewrite this equation by dividing both sides by V2, which gives us M2 is equal to M1 times V1 divided by V2, which is going to be the equation we use. So to set this up, M2 then is equal to M1, which is our initial concentration of 0.100 molars, V1, which is 10.00 milliliters, divided by V2, which is 45.67 milliliters. The milliliters cancel, which will give us an answer in molars. So M2 then, if we plug these into our calculator, it gives us a value of 0.0219 to 3 sig figs, because we have 3 sig figs there, 4 here, 4 here. Finally, let's look at number 32. We start with some amount of solution. Again, this is our V1, our initial volume. This is our M1, our initial concentration. And this is our V2, our final volume. So we can use the same equation. M2 is equal to M1 times V1 over V2. Our M1 is 0.500 molars. Our V1 is 9.85 milliliters. And our V2 is 68.70 milliliters. The milliliters cancel out. Our answer is in molars, which is what we want because it's the concentration. Plug this into our calculator and we get 0.0717 molars to 3 sig figs. Again, 3 sig figs here, 3 there, 4 there. All right, so this brings us then to the end of our dilution calculations. Remember, the equation is M1 V1 is equal to M2 V2. And as long as we know any 3 of these, we can find the 4th one. We just need to manipulate the equation using some simple algebra. If you have questions, as always, you can let me know. Otherwise, I will see you in the next video. Bye.